Welcome back. Let's do question 11C. We have done 11A and 11B. Right, we found the coordinates of C, that the coordinates of C are x at C being 6 and then y at C being 2. And then we found that the radius is 2 here. So the radius is 2 from the previous questions, isn't it? A second circle with center 0, 9 and with point 2, 3 that lies on the circumference is drawn on the same set of axes. Do the two circles intersect? Show all your working. Let's just discuss around this concept. Right, we have two circles like this. Right, let me say they are intersecting at one point. They just touch each other at one point like this. Right, so if you add the small radius and the bigger radius, this will give you the distance between the two centers. Okay, or we can say the distance between the two centers is equal to the sum of the two radii. Okay, they'll be intersecting at one point like that. If they are not intersecting, what we'll do, we'll find the distance between the two centers like this. Okay, we find this distance between the two centers, and then if we add or we find the sum of the two radii, you may find that the sum of the two radii is less than the distance between the two centers. It means they do not intersect when it's like that. The last scenario will be like this. The circles intersect, maybe let's say 2 points like that. And then the distance between the two centers is less than the sum of the radii. Okay, because the distance here is smaller than the sum of the radii. Or you can say the sum of the radii is greater than the distance between the two centers. So which situation is it here? We have a circle with center 0, 9 like this, and then it is another point at 2, 3. Let's say this is point 2, 3. Okay, are these two circles intersecting? So we need to find the distance between the two centers, and then we're going to compare the distance between the two centers to the sum of the radii. All right, this one we know the radius is 2. We need to find the radius of this one. Okay, how do we do that? Let's start by finding the radius of the new circle. So remember, the equation of a circle is x minus a squared plus y minus b squared is equal to r squared. Our a is 0, b is 9, so it's going to be x minus 0 squared plus y minus 9 squared is equal to r squared. So this is like 2 squared. We're substituting the coordinates of this point now, because 2 minus 0 is 2. So it's 2 squared, and then plus 3 minus 9 squared is equal to r squared. So 4 plus 36 is equal to r squared. So 40 is equal to r squared. R is equal to square root of 40. R is roughly 6,3245532. Okay, that is radius there. And then let's find the distance between the two centers. So we're going to say the distance between the two centers, d, is equal to the square root of, say, 6 minus 0, then squared plus 2 minus 9 squared. And then what do you get? We get, this is the square root of 85. And then the distance here between the two centers is 9,219,54457. And then if we add the two radii, this one is 6,32, this one is 2. If you say sum of the radii, right, is equal to 6,32 plus 2, which is 8,32. Okay, so you see that the sum of the radii is less than the distance between the two centers. So it is like this situation, so meaning that the two circles will not intersect, so therefore they do not intersect.